Self-commutation. The thyristor is turned off due to the natural characteristics of the circuit. Now considering the circuit with an assumption that the capacitor is initially uncharged, then Vs equals to Vl plus Vc, that equals to L di by dt plus 1 by C integral I dt plus initial voltage in the capacitor at t equals to 0, and we have assumed that this value equals to 0. The current I at t equals to 0 is equals to 0. Then the solution for this will be getting the charging current I of t is given by Vs square root of C by L sine omega m of t, and the voltage to the capacitor Vc of t is equals to Vs 1 minus cos omega m t, where omega m equals to 1 by root Lc. At 0 degrees, I of t equals to, at sine 0, this is 0, so I of t equals to 0. Now, after that is turned on at pi by 2, I of t will be maximum since sine value is maximum at 90 degrees and is given by Vs square root of C by L. And at pi, sine pi is 0, then this value is 0. Then I of t at pi equals to 0. Now what about the voltages? At 0, cos 0 equals to 1, 1 minus 1, 0. V of C equals to 0. Now at pi by 2, cos pi by 2 is 0. Vc equals to Vs. Now at pi, cos pi is minus 1, minus of minus plus 1, so Vc is 2 Vs. Maximum value is Vs root of C by L. This is I of t, and this one is 0 Vs 2 Vs. It's happening at pi. When omega m of t equals to sine pi, omega m t equals to pi. Now if you substitute the omega m value, t equals to pi square root of root Lc. So at t equals to pi square root of root Lc, the charging current becomes 0 and the thyristor T1 is switched off itself. Once the thyristor T1 is fired, there is a delay of t0 seconds before T1 turns off. So this is t0 seconds from here to here. And T0 may be called as commutation time of the circuit, that is equals to T0. This method of turning off the thyristor is called self-commutation, and the thyristor T1 is said to be self-commutated. Gate current falls to 0, the capacitor is charged to 2 Vs. Now, considering the capacitor has the initial voltage of minus V0 and the thyristor T1 is triggered, Vs is absent, so L di by dt plus 1 by C integral I dt plus Vc at t equals to 0 equals to 0. And the initial condition is this one equals to minus V0. Initial current I of t equals to 0 equals to 0. With these initial conditions, if we find the solution for this, then I of t is given by V0 square root of C by L sine omega m of t, and the voltage across the capacitor C is equals to minus V0 cos omega m of t. And we know that omega m equals to 1 by root Lc at t equals to 0. I of t equals to, this is 0, then the total value is 0. Whereas Vc is, now cos 0 is 1, so minus V0. Now at t equals to pi by 2, I of t equals to, this is maximum value, so V0 square root of root C by L, and Vc of t equals to, this is 0, total value is 0. Now at t equals to pi, I of t equals to again 0, and Vc of t equals to minus of minus plus V0, and omega t equals to pi, t equals to pi root Lc, which is nothing but time taken to turn off the thyristor or commutation time of the circuit, and which is reversing the voltage from minus V0 to V0. So it's also called as reversing time and is represented with PR. Now we'll see that. So at 0, current high is 0. At pi by 2, the current is high and is equals to V naught root C by L becomes 0 at pi. At 0, the voltage is minus V naught. At pi, the voltage is 0. Now plus V naught. This is nothing but reversal of voltage is happening at the capacitor. Now problem on self-commutation. Find conduction time of the thyristor and the capacitor voltage after the commutation, where the inductor is 10 microhenries and 50 microfarads is the capacitor. The initial voltage is V0, which is equal to Vs. Applying voltage is 200 volts, whereas the initial current is 250 amps, that is Im. L di by dt plus 1 by C integral I dt plus Vc at t equals to 0 equals to Vs. And Vc at t equals to 0, V0 or Vs. And initial condition current I at t equals to 0 is equals to Im. Solution for this is I of t equals to Im cos omega m of t. And Vc of t equals to Im root L by C sin omega m of t plus Vs. I of t. And omega m t equals to 0. I of t equals to Im. When omega m t equals to pi by 2, cos pi by 2 is 0. So I of t equals to 0. 0 pi by 2, and this value is Im. At omega m t equals to 0, sin 0 is 0 value, then V of c of t equals to Vs. When omega m t equals to pi, then Vc of t equals to Im square root of c by L plus Vs. V of t. This is our conduction time, that is omega mt equals to pi by 2, then conduction time t naught equals to pi by 2 by omega m. Omega m is nothing but 1 by root Lc, then pi by 2 of root Lc. Now substitute this values, that is 0.5 into pi root of 50 micros, 10 micros. Then if you calculate this, 35.12 microseconds. This is our conduction time T naught. Now we need to find out the voltage of the thyristor commutation, which is nothing but at the current crossing 0. Then V of c of t at 0 equals to Im. Im is 250 amps square root of 50 microfarads divided by 10 microhenries plus Vs is 200 volts. When you calculate this, you will be getting 311.8 volts. This is the voltage across the capacitor after thyristor is turned off.